Hi everyone, we're still doing mathematical induction, but this time using sigma notation. Show by mathematical induction to prove that the summation of 3i from I equals to 1 to n is equal to 3n times 1 plus n over 2. So the first step is to prove that the statement is true when n is equal to 1. So that's 3 times 1 is equal to 3 times 1, 1 plus 1 over 2. So 3 is equal to 3 times 2 is 6 over 2. So 3 equals 3. So that's our first step. Second step is to prove the statement is true, or to assume that the statement is true when n is equal to k. So our summation equation will be like 3i, I is equal to 1 to k. So now the n will be 3k times 1 plus k over 2. And then the next step is also to assume if n is equal to k, then it could be true when n is equal to k plus 1. So what will happen here is, so the summation of 3i, I is from 1 to k plus 1 is equal to 3. Then let's substitute our k with, or our n with k plus 1. So k plus 1 times 1 plus k plus 1 over 2. Let's simplify this as 3 times k plus 1 times k plus 2 over 2. So now if we're going to add our inductive term for n equals k plus 1, so that would be, so 3i, summation of 3i from I is equal to 1 to k plus 1. So that means that it's the summation of 3i from I equals to 1 to k plus the next term 3 times k plus 1. So let's substitute this here. So that is 3k 1 plus k over 2 plus 3 times k plus 1. Okay, let's remove some or clear some space. And then let's simplify. Find the LCD. So this will be 3k 1 plus k plus 6 k plus 1 over 2. So this will be 3k plus 3k squared plus 6k plus 6 over 2. Okay, let's write it here. So let's combine like terms. So that would be 3k squared plus 9k plus 6 over 2. Simplifying, factor out 3. Then we'll have k squared plus 3k plus 2 over 2. And then let's factorize. So that would be 3. And k plus 1 plus 2 over 2. And therefore, we prove by mathematical induction that this is true.